Hello everyone, welcome back to my study Pathshala. Today we are going to start with exercise 1.1 from real numbers. This is very important exercise for board exams. Usually a lot of board questions come from this chapter. So we'll start with exercise 1.1 question number 2 first part. This is very important and usually CBSE asks it for 2 to 3 marks. So second question, first part is find HCF and LCM of 26 and 91 and also verify the relationship, which is HCF into LCM equals to product of two numbers. So step 1 would be to find the prime factors of 26 and 91. So we'll start with 26. So prime factors of 26 are 2 into 13. Similarly, prime factors of 91 are 7 into 13. Now, as we remember from the last video, HCF is equals to smallest power of common factors. So we'll see which are the common factor in 26 and 91. So we'll see the common factor is 13 in both of them. So smallest power of 13 here is 1. So we are taking HCF as 13. Similarly, we'll find LCM, and as you remember from the last video, LCM is equals to greatest power of all the factors. So we are going to take all the factors. So greatest power of 2 is 1 only, so we are taking 2 raised to power 1. 7 has the highest power of 1 only, so 7. 13 has the highest power of 1, so 13. So 2 into 7 into 13, which gives us 182. So LCM into HCF equals to 182 into 13, which will give us 2366. Similarly, also the product of two numbers would be 26 into 91, which is also 2366. Now since LCM into HCF is equals to the product of two numbers, so we have verified the result. Similarly, you can solve second part and third part also by the same method, and you can try it as homework. So now moving on to question number 4. It is a very easy one marker question, usually which comes in board exams. In this question we are given that HCF equals to 9. Two numbers are given to us which are 306 and 657. We have to find LCM in this question. So in order to solve this question, we are going to use a formula which is HCF into LCM equals to product of two numbers. This is the same formula that we have verified in the previous question. So we'll just substitute the values here. Instead of HCF, we are substituting 9. LCM we have to find, so we are going to leave it as it is. Product of two numbers, we are writing the numbers 306 into 657 because product means multiplication. So here 9 would be transposed to the right hand side. Here it is in multiply with LCM, so it will divide the side. So LCM is equals to 306 into 657 divided by 9. 9 and 306 can be cancelled. We are left with 34. So 34 into 657 will give us 22,338. You can use this type of questions by this formula whenever, let's say, if HCF is given and you have to find LCM, or if LCM is given to us and we have to find HCF. So either case we can use this formula. Okay, now question number 5 is, can 6 raised to power n end with a 0? So this is a very important question for board exams also, and it is asked in various forms. Like there could be a question, can 4 raised to power end with 0, or can 12 raised to power n end with 0, or it could be 15 raised to power n end with 0. So first of all, to understand this question, let's understand the logic behind it. So let's take for an example numbers which are ending with 0 to understand what's the logic behind it. So 10 we are taking, 20 we are taking, and we are taking 100. Let's take the prime factors of 10. 10 can be written as 2 into 5. Prime factors of 20 can be written as 2 into 2 into 5, which gives us 2 square into 5. Similarly, 100 can be written as 2 into 2 into 5 into 5, which could be written as 2 square into 5 square. So if we observe all of these, what do we get? That for a number to end with 0, it must have 2 and 5 as prime factors. And both of them are very, very essential. Let's break down 6 raised to power n. 6 can be written as 2 into 3. 6 raised to power n can be written as 2 into 3 whole raised to power n, which could be written as 2 raised to power n into 3 raised to power n. So as you can see, there is no factor of 5 anywhere here. So 6 raised to power n can never end with a 0 for any natural number. So remember guys, any number ending with 0 must have 2 and 5 as factors. So check for both of them. Next is question number 6. This is an application based question of prime and composite numbers. So you would know whether you have understood the concept of prime and composite if you are able to solve these type of questions. Let's check. In this question it says explain 7 into 11 into 13 plus 13 is a composite number. So in order to solve this number, let us first of all see 13 is common in both of them. So let's take 13 common. So we are left with 7 into 11 plus 1. 7 into 11 is 77. 77 plus 1 is 78. And we'll make the factors of 78, which would be 2 into 3 into 13. So 2 into 3 into 13 is here, 13 is here. So we can write it as 13 square. So since there are more than 2 factors, therefore it is a composite number. In case you have forgotten what are prime numbers, what are composite numbers, you can check our earlier videos regarding this. Second part it says explain 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. So we'll solve this also similar to the first part. We'll take 5 common from both of them since 5 is common here. So we are left with 7 into 6 into 4 into 3 into 2 into 1 plus 1. So this whole gives us the multiply of 1008. So 1008 plus 1 is 1009. So here also we are getting 2 factors, 5 and 1009. Now since there are again more than 2 factors, therefore it is composite. Now you would ask, I have only taken 2 factors. How I can say more than 2 factors? So if you remember our earlier video, for every number, a number itself and 1 is also a prime factor. So we have got here 1, 2, 3 and 4 factors in total, because 1 is also a factor, number itself is a factor, and 5 into 1009 is also a factor. So whenever you see an expression where you can take a common factor, that number would always be a composite number. So this is a trick that you can apply for your competitive exams also. Let's move on to question number 7. So now this type of a question is the real life application of LCM. Let's see what's given in the question. Sonia takes 18 minutes. Ravi takes 12 minutes. They both start together. When will they meet again? So there is a shortcut trick for these kind of questions. Whenever you see a word written as maximum, greatest, longest or largest in the question which is asked, so you have to always find HCF. And if it says least, minimum, meet again, repeat or together, in that case you have to find LCM. So here you can say they start together, when will they meet again? So this is the question of LCM. So in order to find LCM, let's first of all make the prime factors of 18 and 12. So prime factors of 18 are 2 into 3 into 3, which gives us 2 into 3 square. Similarly, prime factors of 12 are 2 into 2 into 3, which is 2 square into 3. So LCM is equals to, so as you remember from the earlier videos, LCM is the highest power of all the factors. So we have seen 2 is here, 2 is here, here 2's power is 1, here 2's power is 2. So we are taking the greatest power, which is 2 square. Similarly, in case of 3, it has power 1, it has power 2. So we are taking 3 raised to power 2. So it becomes 2 square is 4, 3 square is 9, 4 into 9, which is 36. So the answer would be 36 minutes. So they will meet again in 36 minutes. So these type of question or such a questions are very, very important in case of case-based questions, and it is regularly being asked by CBSE. With some bonus questions which are very, very important for board exams. If HCF of 65 and 117 is 65m minus 117, we have to find m. So it says HCF is already given to us. So let's find the HCF also, what it actually would be. So 65 equals to 5 into 13. Similarly, 117 can be written as 9 into 13. So we'll see the common factor here is 13 in both of them. So HCF of 65 and 117 comes out to 13. So now what was given in the question was 65m minus 117 was the HCF. So we are going to equate both of them. So 65m minus 117 equals to 13. So we're going to transpose minus 117 towards right hand side. So it becomes plus 117. Now we are going to transpose this 65 towards that side. So 13 plus 117 has become 130. 130 divided by 65. So 65 2s are 130. So we've got the value of m as 2. So now the bonus question 2 is find the largest number dividing 70 and 125, leaving remainders 5 and 8 respectively. So in order to solve this question, we have to understand like what would be the numbers actually that would be divided by the largest number. So the number would be dividing 70 leaves the remainder 5. So 70 minus 5 would be 65. And similarly 125 minus 8 would be 117. So we have to find the HCF of 65 and 117. Why the HCF? You can remember the trick earlier. It says find the largest number. So we have to find HCF. So let's find the prime factors of 65 first of all. Prime factors of 65 are 5 into 13. Similarly, prime factors of 117 are 3 into 3 into 13. So as you can see, the common factor here is 13. So HCF of 65 and 117 is 13. So 13 would be the largest number that would be dividing 70 and 125, leaving remainders 5 and 8. Now the third bonus question is if a equals to x cube into y square and b equals to x y cube, find HCF of a comma p. So now since we remember that HCF is the product of smallest power of the common factors. So let us look at the smallest power of the common factors. So first common factor is x in both of them. So its power here is 3, power here is 1. So smallest power is x raised to power 1. Similarly in case of y, it is y square, y cube. Smallest power is y square. So the HCF would be xy square. So let's start with the quick revision now. What all we have studied today. First was LCM into HCF equals to product of two numbers. And please do remember this thing, which is very, very important, that this result is not true for three numbers. It is only applicable for the product of two numbers. Secondly, numbers ending with 0 must have prime factors of 2 and 5 both. And thirdly, composite numbers are those which have more than 2 factors, or when you can take a common factor out of them. That's all for today. If you found this video helpful, please like it and share it with your classmates. Also, you can subscribe for more such content or such videos. All the best. See you in next video. Bye.